Hello people of the internet, my name is Kyle and welcome to my video on CNN libraries. Today I'm hoping to be able to teach you all the wonders of CNN libraries. Hopefully by the end of this video you'll be able to not only see the differences between each library I cover, but what the individual purpose is for them and how that can apply to your specific project. Now before we begin, I have to apologize here. The audio equipment I'm working with is rather new, so I haven't calibrated it yet. So there's going to be some background noise that I cannot handle right now. Hopefully later on I'll be able to edit this video and make it sound a bit better and look a bit nicer with new graphics and whatnot. But for the time being, I'm going to continue onward and try to get this information out to you. So let's get started. So before we even begin about the different CNN libraries there are, there's probably something I need to get out of the way first, which is what is a CNN? And no, I'm not talking about the news station. A CNN is short for convolutional neural network. It is essentially, to be overly simplistic about it, the way that deep learning programs can actually learn. It captures some of the raw data that comes through the network. And once it collects this data, it'll train itself to say, hey, the bar is farther down from here, we need to get going. So we go down a little lower and a little lower and a little lower until it reaches zero. CNNs are pretty useful things. They allow us to do quite a lot in stuff like image processing, where you're trying to say identify the image of a cat or a dog. You feed it a whole bunch of images of the same type of dog at different angles. It'll eventually train itself to identify that dog. Furthermore, if you add multiple dogs that look similar to the first one and you keep filtering those pictures, so eventually it's going to learn the stereotypical image of a dog. And that'll be very grateful for robots that are trying to avoid living things that are maybe lying on the road or something like that. CNNs are involved with more cool things than just what I've said, but for the purpose of this video, we need to keep moving forward. Let's start with the first library I investigated on this project. It's a library called TensorFlow. Now, TensorFlow is a relatively new library that came out just a few years ago. The really cool thing about TensorFlow is how easy it is to use for both veterans and newcomers alike. The UI is top-notch for this program, and another thing that adds to its prestige is the fact that it's created by Google. They made this as part of their Google Brain program so that they can try to understand deep learning programs, try to dive more into the architecture and the knowledge for it. And then they decided just a few years ago to make it open source for everybody, which the community really, really loved Google for it. In fact, the community is still going really strong even to this day because they opened up the doors and everyone was able to go in and check the open source code, be able to make their own edits, be able to get involved and use the highly advanced tool set that is available inside TensorFlow. Now, there are a few downsides with TensorFlow. One of the biggest being the fact that it is a GPU hog. So when you are running TensorFlow, you need to be careful how much you're letting it use your GPU. Otherwise, you're not going to be able to run much else in the background while that thing is just gobbling up the power to process the operation that you're handling. Also, at the moment, it doesn't have very nice documentation on some of its more advanced things. You're going to have to rely a bit more on the community to try to help you out. And lastly, it does not like playing nice with Thano. It and Thano do not mix well together, so don't try mixing code back and forth between them. It's not going to be pretty. Granted, it's not the best one on this list for all purposes, but it definitely is a great one for starters. Now, the next one on this list is really hard to pronounce, so excuse me if I destroyed this pronunciation, but Thano. Thano is a older deep learning program, one that's actually been around since at least 2008. This is one of the oldest ones you can get your hands on, and it does show. One of the good things about Thano is the fact that it's based off Python. So the fact that if people know how to use Python, it can translate really well over to Thano. And Thano, being it so old, has had a lot of time to mature and be able to develop its own list of documents and community guidelines that help newcomers that want to use this program really get into the meat of things and try to use what is there. Sadly, this is the part where Thano really starts to show its age a bit because it can only handle so much actual processing and deep learning stuff. It's rather good with numerical computation, but with anything else, it's subpar compared to what's out there. I mean, the fact is that Thano is actually used as the foundation for a lot of different types of deep learning programs are out there. Just because it was one of the first ones on the floor with the open source and people wanted to try to improve what was there and make it better. Now let's move on to the next player on this list. It's a more advanced program than either TensorFlow or Thera, and it is called Keras. Yes, and I mean the emphasis on the S. I mean the word Keras. That just screams wanting the extra S emphasis on it. Alright, that's enough of the sidetrack. Now the really weird thing about Keras is the fact that it is actually a program that is a hybrid of the prior two I just mentioned. Now you can configure Keras to actually work over top either TensorFlow or Theras, which is really interesting because that means that it's not able to just use what it has, but use most if not all the features of the host program it's operating on top of. That means you can use a lot more customization and a lot more advanced tricks in your program. And like I just mentioned, it is really a flexible program. The fact that it has all these additional features that go on top of Theros or TensorFlow makes it just really easy. And it has a well-designed UI interface to boot. The one major downside of this relatively new program is that it cannot use multiple GPU support. So if you're going to run it, you're not going to be able to get the maximum amount of power going through it since it only has the maximum 1 GPU allowed per operation. Now, this last one, I don't know how thirsty these guys must have been in order to think of a name like this, but the last one is called Caffe with 2 F's. I don't even know. But to get back on track, the one unique thing about Caffe is the fact that it is one of the largest used programs in terms of academics. Professors, scholars, students, a lot of these people are using Caffe to do their deep learning research, and it's being shown all around the world through their publications. Now keep in mind, Caffe is primarily an image processing system. So it's one of those programs that sits image through and expects to get information from it via dog, cat, blue sky, something like that. And actually, the website proudly states that, I quote, Caffe can process over 60 million images per day with a single NVIDIA K40 GPU. Now, I don't exactly know what a K40 GPU is, but the fact that they're trying to boast something that big on their actual website, I hope that holds some water in terms of how powerful this thing actually works. Sadly, this is where Caffe starts to tamper down as a deep learning program because of the fact that, unlike the others, it is very, very sturdy. It does not like adjusting from what it normally does, and people who want to try to add parameters with it tend to have a real difficult time doing so. It's not impossible, but it is definitely a hard time that can be better used in a different program. So of the 4 libraries that I have presented to you, you gotta ask yourself which one sounds the closest to what you're looking for. Because, for instance, if you really just want to try to get into the community, you want to get your feet wet in something easy but still very manageable, you can use Theos or TensorFlow. TensorFlow is probably the better option of the two because there is a more lively community on there compared to the other one. But it has to be said that Theos is also a viable option if you want to start with the older stuff and try to work up through branching libraries and different programs that connect to that Python based originality somehow. But if you're really looking for something that has all the new tips and tricks of the industry wrapped up in a nice package, then Keras is probably what you want to look for, especially since that can link directly to either TensorFlow or Theos. And the abilities of this thing is matched perfectly with the simple UI interface that makes the whole thing look surprisingly underpowered, but it can actually hold its own quite well. And if you're looking for a program that's more closely related to academics, or you just want to have a really powerful image processing program, then Caffe is probably the best thing for you, since it really does not deviate from that path and is used quite frequently across this globe by a bunch of academics. In the end, though, there's not one perfect solution for all the problems, so you have to decide for yourself which one feels the best for your situation. Maybe you have one really powerful GPU, so you don't mind the way Keras is set up, or maybe you have two weaker ones in SLI that make one better GPU, but you can't really take advantage of that extra processing power. And there is also the fact that there are more deep learning programs than just the four I have listed here. You could go out there and do some digging on your own if none of these felt suitable for you, and you can find probably one that meets your needs. More often than not, if you have an idea, a concept that you want to do, someone else has probably have done that before, and they wanted to make something that would work well for that case. And honestly, the future for deep learning is only going to get brighter. There's going to be more specified programs for special cases. They're going to become more advanced as CPU and GPU power increases. They're overall just going to become a lot better faster. It's going to be a nice shiny future, and I hope we all can enjoy it. Alright everybody, I'm going to end the video here. I hope this was useful for you, and hopefully you'll be able to find the right deep learning program that you need to do whatever you want to do. As always, please like my video if I did a good job. Please leave a comment below if there's something I can improve on. And I hope to see everybody in the next video. Have a good night.